Hello everyone. Today let's solve the problem number 978, longest turbulent subarray, right? So let's see what the question states here. We have to find the length of the longest subarray where the relation between adjacent number alternatives greater than or lesser than, right? So greater than, then lesser than, then comes the greater than again, or the reverse, right? So lesser than, greater than, lesser than, like that, right? So we have to find the length of the, again just give me a second here, 1 second. Yeah. We have to find the length of the longest subarray where the relation between adjacent numbers alternatives, so whether it can start from greater than, less than, greater than, and so on, right? So also this one, or the reverse, right? First it can be less than, then greater than, less than, and so on, right? So it can be like this in this format, right? So uh, equal adjacent values break turbulence, right? So equivalent adjacent values break turbulence, right? So this one will break the turbulence. Just keep this in mind. And also we have to return the maximum turbulent window length. What we need to return here again, in simple terms, we have to return the maximum turbulent window length, right? So this is it for the problem. This is it for the problem. See here, we have 94278819. Array 1 is greater than array 2. See here, this one, we know 9 is greater than 4. Fine. And 4 is greater than 2. Yes, fine. And 10 is greater than this one. What do we call? 10 is greater than 2. This is fine. Then finally, so sorry, 1 second. 4 is greater than 2. This is fine. And so, sorry, I considered from 9, I guess, right? So we are going with a 4. Basically, we are starting from the 4 until here, right? So 4 is greater than 2, right? So see here, just give me a second here. Yeah, 4 is greater than 2 here. So we have to go with a certain this thing, right? Criteria. So greater than, less than, greater than, less than, like that, or less than, greater than in that format, right? So see here, 4 is greater than 2. Then 10 is greater than 2, right? 10 is greater than 2. So this is fine. Then 7 is less than 10. 7 is less than 10, right? And 8 is greater than 7. Right? So this is fine. So until here we can go. Next it will be equivalent to 8, we cannot consider. Right? So these 5 we can consider. Right? So these 5 we can consider. This is the what do we call? Maximum turbulent window length basically. So see here, this is one length we have to display, right? So 1, 2, this one is 3, this one is 4, this one is 5. So the length that we need to return here is 5. So that's what they have given here, right? Same goes with example 2 and example 3 as well. You can just check it out in the same way. So this is fine. Now let's do one thing. Let's quickly discuss the approach followed by the this one complexities, and then let's write the code. Right. So first, as usual, let's discuss the approach first. So just give me a second, 1 second here. So yeah, now what we have here within the example. So let's consider the same first example for the approach. So here we'll be going with a greedy. Just remember, we will be going with a greedy approach, right, to solve this particular problem. Just remember this one, right? So here I'll be telling certain things. So just listen to this. U is nothing but the length of the turbulent subarray that is ending at I, right? So D is nothing but the length where last step is down. And uh, initially U equals D equals 1. Just remember this one, these three things. When I say, don't get confused, right? So we'll be considering first example for the this one. What do we call? Approach, right? First I is 1. It starts 1 1. I equals 1. So we will check whether 9 is greater than 4. Yes, 9 is greater than 4. Now D will be equivalent to 2 and U will be 1, right? U will be 1. Best will be 2 basically here, right? Best will be 2, right? So next we will go with I equals 2. Next we will be going with I equals 2, meaning we will check whether 4 greater than 2, right? So we'll check whether 4 greater than 2. Yes, 4 is greater than 2. So D will be 2 itself and U will be 1. Best will be again 2 here. Best will be again 2 here. This is fine. Now let's move on with when I equals 3 here. Uh, so I equals 3, we will check whether 2 is less than 10, because we have to go with greater than, less than, this one, greater than, less than, or this one, less than, greater than, less than, greater than, in that format, right? So now we will check whether 2 is less than 10, right? So 2 is less than 10. Yes, 2 is less than 10, right? So u, we will be incrementing u, and nothing but u becomes 3, and d will be 1 this time. So best will be quite obviously 3. Best will be 3 now, right? So we will check for 4. When I equals 4, we will check whether 10 is greater than 7, whether 10 is greater than 7. Yes, 10 is greater than 7. When I equals 4, whether 10 is greater than 7. Yes, 10 is greater than 7. Now D will be 4 and U will be 1. Best will be 4. Right, same goes with I equals 5 as well. So this time we have to check for less, right? So whether we will check whether 7 is less than 8. 7 is less than 8. We will go with U equals 5, and D will stay as 1 itself. So best will be 5 this time. Best will be 5. Instead of 4, best will be 5. Subarray that we got here is, until here, the subarray that we got here is 4, 2, 10, 7, and 8. Right? So this is the subarray that we got. 7 and 8. 8, I'll just write this one below. This is fine. This is the subarray that we got. And next what we will do, we will go with I equals 6. So we will check whether 8 is, previously 7 was less than 8. 8 is greater than 8. No, right? This is not possible. Basically, I'll not write anything here. So next we'll go with I equals 7. Uh, Now we have to check for this one. What do we call? Again, 8 is greater than 1. Yes, it is. From here, so D, we will go with D equals 2, but the best remains 5 itself. But the best remains 5 itself, right? So best remains 5 itself, because this is the first number. Again we have to start here. It got it got broke, right? So here, so we have to start with again. So best remains 5 itself. So next number we will check I equals 8. 1 is less than 9. 1 is less than 9. So we will increment u this time, but best remains 5. Right, so we have got 2 now, 2 and 5 among the best. So best remains 5 itself. We will consider this array. We are done with the array part, right? So we are done with the array elements basically. So until I equals 8, I have shown you. So see here, I equals, we have started from here, 2, 3, 4, 5, right? No, 1, 2, 3, 4, 5 basically. 0 will not be considering because 9 is greater than 4, is not required, right? So next it will fail. So that is the reason we'll be going with 4 greater than 2. From 4 greater than 2 we'll be considering. So this one, I equals 1 to I equals 5. So the array elements are 4, 2, 10, 7, and 5. So we need to return its length basically. 1, 2, 3, 4, 5 we got here. So we got here I equals 5, right? So best equals 5 basically. So that best, this one, the last best was 5. That 5 we will return as output. So the output that we got here as 5, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct in this case, right? So as we are completely familiar with the approach, let's discuss the complexities part very quickly, man. Right, so what will be the time complexity here? As I've said, we'll be going with the greedy, right? So greedy usually will be going with a single pass, right, from left to right, right? So we'll be going with a single left to right pass, constant work per element. So overall time complexity would lead to big of n, right? So this is time complexity. So what would be the space complexity here? The space complexity would be big of 1. So here we will be making use of only few integer variables, u, d, whether it may be any resulting variable, answer, result, anything that we consider, right? So it will be big of 1. Overall space complexity would be big of 1. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of 1 respectively, right? So this is fine. Now we are done with the complexities and the approach part. As we are completely familiar with the complexities and the approach part, we are good to write the code. Let's start writing the code. Right. Now, first we'll be making use of the length of the array everywhere. So let's do one thing. Let's go with number of elements here. N equals nothing but the number of element. So let me assign this one to array.length. So we'll be making use of array length everywhere. I'm just assigning this one to the variable, right? So this is fine. So now one thing from the approach that we know here is if there is at most one element, the longest turbulent subarray is the array itself from the example 3. See here, this one I'm speaking of. So this would be the base case, and let's write this one. Nothing but here, if n less than or equal to 1, then we can just directly return n here. This is fine. Now, as I have said, u is nothing but the length ending at the current index with a last comparison up, basically, right? And d is nothing but the length ending at the current index with a last comparison down. So for the up, it is array of I minus 1 less than array of I. For the down, it is array of I minus 1 greater than array of I. Simple. Let's initialize u and d first. So this will be u equals 1, d equals 1 as well. So let's consider any result variable. I'll just go with answer here, ans. So let me assign this one to the 1. This is fine. Answer is nothing but the best maximum length that we have found so far. At least it has to return 1. So I'm considering 1 here. So it cannot return empty array, right? At least it has to return 1. Because see here, if n is less than or equal to 1, we are returning 1, right? So one element has to be present. So best has to be 1 at any case. Now this is fine. Now let's move on with the iteration part. We have to iterate from the second element to the end, right? So let's do that. So this one will be for int I equals 1, uh, I less than n. So this one will be I plus plus. So within the for loop, let's go with simple if condition here. Array of I, if it is greater than array of I minus 1, then within the if condition, what we'll do, let's go with the current step, that is up. Current step is up. We have to extend the previous down chain, and we have to reset down, right? So let me go with u equals d plus 1 and d equals 1, right? So this is fine, man, right? So let's do one thing. I'll just go with else if here. So this one, array of I, so this one less than array of I minus 1. Then what we need to do, we have to go with the current step, that is down, and we have to extend previous up chain and reset the up, right? The reverse of the previous one, right? So current step was up, so we extended the previous down chain and then we reset down. Now the current step is down, so we have to extend the previous up chain, and we have to reset up, right? So this one I can write it on this way: d equals u plus 1, and u we have to assign this one to 1, right? Else we are left with last condition, nothing but when the equal values break the turbulence, right? So 8 equals 8, that broke the turbulence in our case here. This one, 7 was less than 8. Next 8 has to be greater than 8, right? So this broke the turbulence, right? Here in this case it was equal. So equal values break turbulence, we know. We have to reset both the lengths. So in that case, u and d we have to assign this one to 1. U equals 1, d equals 1. Simple. Let me come out of this one entirely. Now we need to update the global best with whichever is larger at this position, meaning if u is greater than answer, then answer, let me assign this one to u, right? Again, if d is greater than answer, then answer we have to assign this one to the d, right? So answer equals d. Simple. Now we are left with the last step, nothing but we need to return the longest turbulent subarray length that they have asked in the question, which will be stored in the answer variable, right? So I'll just go with return answer initially, which we considered 1, right? Initialization part. So now we have successfully returned the answer variable. This is fine. This is it for the code. Let's see whether this works or not. Let me run this one. We have cannot find the symbol ans, so I haven't in oh I haven't given int, I guess. Directly I have written ans, yeah. So this is fine. Let me run this one again. Yeah, now you can clearly see the sample test cases are getting passed. So let me hit the submit button. You can clearly see here all the test cases are getting passed, means the code works absolutely correct in this case, right? uh, I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.